In this video, we're going to talk about linear functions. Now, linear functions have a couple of special properties that I want to talk about before we get into a couple of examples involving these kinds of functions. These special properties are that these functions have an infinite domain and range, which we can illustrate by just drawing a line on a graph here. As you can see, it goes infinitely down, up and down. So it covers the entirety of the y spectrum, and it also goes infinitely left to right, so it covers the entirety of the x spectrum. So you can pretty clearly see that this thing has an infinite domain and range. Some functions aren't like that, and we'll get to those later on. I have a couple of videos up on the channel if you want to take a look at those. Another special property of these linear functions are their constant rate of change. All linear functions have a constant rate of change, which is equal to a, or the slope of the linear function. So this a is going to be the rate of change from here to here, and here to here. It'll be this rate of change, and it'll be this rate of change. It'll be the rate of change for any point along the entire line. Okay, now that we've gone over the special properties, let's look at a couple of problems involving these linear functions. Okay, so here we have a quick example. Suppose Susie wants to start a lemonade stand. It costs Susie $10 to buy a table, $2 for each cup, and $1 for each lemon. And that's all we're assuming it takes to make a glass of lemonade. In this case, is just a lemon in a cup. A little unrealistic, but we'll move with it. How much will it cost for Susie to sell 5 cups of lemonade? We want to use a linear function, because that's what we're looking with here. But the reason we know we want to use a linear function is this verbiage for each. We have $2 for each cup and $1 for each lemon. That means each time she buys a cup or each time she buys a lemon, it's going to cost her $2 or $1 respectively. So we know that that is our AX in this case. For each cup, it's going to cost Susie $3 because she has $2 for the cup and $1 for the lemon. So we're going to write function C. That's what we'll call our cost. And our cost is going to equal 3 times the amount of cups she's making, because for each cup it costs $3 combined. We're going to say 3 times n, where n stands for the number of cups that Susie makes. But it also costs her $10 to buy a table, but she only needs one table to sell as many cups as she wants. So we'll count this $10 table as a one-time purchase, which goes into this B up here in this linear model, because no matter how many cups she sells, this letter N, she's only going to have to buy one table. So that's plus 10. Okay, so now we have our cost function, and now all we have to do is plug in 5 cups for N. So if we plug in 5, we get C of 5 equals 3 times 5 plus 10. That will be 15 plus 10, which is 25. So it's going to cost Susie $25 to sell 5 cups of lemonade. Okay, let's move on to a kind of part B of this type of problem. Okay, so now we're going to look at a kind of follow-up to this type of problem. Now that we have our cost function established, 3 times n, which is composed of the $2 for the lemons and the $1 for the cups, or vice versa, I don't remember exactly which one it was. But this is 3 times the number of cups she sells, plus $10 for the table. This is her cost function. So now we need to figure out if she sells 5 cups, which we established to be a $25 cost, how much does she need to sell each cup of lemonade for to break even? Okay, well let's look at this and let's use another linear function. Because for each cup she sells, she's going to make a little bit more revenue. So it's going to be something of the form AN plus B, where N is the number of cups we're selling. But Susie doesn't get a base revenue here. She doesn't get anything just by her lemonade stand existing. She only makes money when she sells cups of lemonade. So this B is just going to be 0. So I'm going to go ahead and remove that there. So we just have a function AN. So now we need to figure out what this A needs to be for Susie to break even, which her cost is 25 up here. But for Susie to break even, her revenue, RN, needs to equal her cost, CN. But we know that we're looking for when Susie sells 5 cups of lemonade. So R5 must equal C5, like that. But we know what C5 is. We calculated that on the last board. That's 25. So R5 is this function here with 5 plugged in for n. So let's go ahead and write that. That gives us A times 5 equals 25. But now this is pretty simple to see. We can divide 5 from both sides, and that gives us A equals 5. So that tells us that Susie, if she wants to break even, needs to sell 5 cups of lemonade at $5 a piece. And that's good enough for now.